screw gauge, and we are also going to look at how we can find readings on the micrometer screw gauge according to our syllabus here. Okay, so without wasting much of our precious time, let us get down into business. What is micrometer screw gauge? Okay, so if you remember very well, last time we looked at instruments that we can use to find length. So micrometer screw gauge is among the instruments that we can use to find length. So today we are going to give detailed knowledge about micrometer screw gauge. So therefore, I'm appealing to you to pay attention so that we can move together. Okay, so what is micrometer screw gauge? So let us begin by emphatically defining micrometer screw gauge. Okay, so we need to remember that micrometer screw gauge is an instrument used to measure small lengths, thickness, and diameters. Micrometer screw gauge is an instrument used to measure small length. Take note, this one specializes in measuring small length, thicknesses, and diameters. So this is how micrometer screw gauge looks like. Okay, so from there we are also going to look at the parts of micrometer screw gauge. Okay, so the first part that we are going to look at the flame. So what is the function of the flame, or where can we find the flame? Okay, so this is the flame, this is the flame, this is the flame. So the function of the flame, or the shape of the flame, the flame looks like C. Okay, it is C-shaped. The C-shaped body or part that holds all other parts together. So the flame holds other parts together. Okay, so this is the flame. We have seen the function of the flame. We are also going to look at this part here, which is anvil. So the function of the anvil is a fixed measuring surface. Where can we find anvil? So anvil is here. So this one is fixed. So when we say fixed, we are simply saying this one cannot make movement. So as we can see, it is stagnant here. It is not making movement. It is immovable. It cannot move. As we can see, this one is moving. This one is not moving. So anvil is a fixed measuring surface. A fixed measuring surface. So this is one of the parts of the micrometer screw gauge. Okay, so the next part that we are going to look at the spindle. So what is the function of the spindle? So a spindle is a movable. So when we say movable, it is able to make movements. Okay, it is able to make movements. And the function of the spindle measure the spindle ensure a spindle, a movable ensuring surface opposite to the anvil. Or we can say the function of the spindle and the anvil is to hold the object being measured by the micrometer screw gauge. So where can we find the spindle? So this is the spindle. So as we can see, it is movable. It is able to move. It is moving back and forth. As we can see, it is able to move. So this one is a movable measuring surface opposite to the anvil, moved by turning the thimble. So this one is able to move provided we are able to turn or rotate the thimble, which is here. So this one can only move if we can rotate the thimble. Okay, so we have looked at the spindle. Let us look at the next part of the micrometer screw gauge. So the next part of the micrometer screw gauge we are going to look at the sleeve or barrel. Okay, so what is sleeve? How can we describe sleeve? So a sleeve or barrel is a fixed cylindrical part with a linear scale marked on it. So where can we find sleeve? So sleeve is here. So this is the sleeve. So this is where we can get the main scale or the main reading. Okay, so sleeve scale is also called the main scale. So this is the sleeve. This is the sleeve. So as we can see, the sleeve is also fixed. It is not making movement, as we can see. This one is making movements. This one is also rotating. This one is rotating. This one is rotating. But this one is not rotating. It is fixed. So no wonder we are saying it is a fixed cylindrical part with a linear scale marked on it. Okay. Or we can say the straight scale marked on it. So the scale which is here is in a circular dimension. This one is in a linear dimension. Okay, in a linear dimension. So this is the sleeve. So sleeve is also called a barrel. Sleeve is also called a barrel. So the next part that we are going to look at, we are also going to look at the thimble. Okay, so thimble is a rotating part with a circular scale. Thimble is a rotating part with a circular scale. Okay, so to move the spindle, which is here, we need to rotate the thimble. So this one can only move provided we are rotating this one. Okay, so no wonder we are saying thimble is a rotating part. So thimble contains, or thimble is made up of a circular scale. Thimble is made up of a circular scale. So circular scale is obtained from the thimble scale. So here is the thimble scale. Okay. So as we can see, we have an illustration here. We can see the object being measured by the micrometer screw gauge. So we have envoy and we have the spindle. So these two are holding the object given here. So and this one can, these two can only hold this object if we can able to rotate this one, as we can see. Okay, through rotating this one. So we have described thimble. Let us see also look at the next part. So the next part that we are going to look at is ratchet. So what is the function of the ratchet? Okay, so the function of the ratchet is to ensure consistent pressure, to make sure that consistent pressure is applied for accurate measurement. So without consistent pressure, accurate measurements cannot be attained. So therefore, it is imperative for you to apply consistent pressure. Okay, and it is the duty of the ratchet to make sure that consistent pressure is applied to achieve accurate measurements. Okay, so where can we find the ratchet? So here is the ratchet. So this is the ratchet. So the function of the ratchet is to ensure that the consistent pressure is applied to achieve accurate measurements or accurate readings. Okay, So the last part that we are going to look at, we are also going to look at locking lever. We are going to look at locking lever. So where can we find the locking lever? So the locking lever or the locking nut is found here. So what is the function of the locking? What is the function of the locking lever or the locking nut? So the function of the locking lever is to hold the spindle in place. Okay, to hold or locks the spindle in place. So this spindle is locked here. As we can see the nut here. So this is the locking nut or locking lever. So the function of the locking lever is to make sure that this one is held nicely without without making unnecessary movements. So in a simple language, we can say locking lever locks the spindle in place. Locking lever locks the spindle in place. So this is the locking lever or locking nut. Locking lever or locking nut. So the next aspect that we are going to look at working principle. So we are going to look at how micrometer screw gauge works. So the micrometer screw gauge works based on the principle of screw, or the micrometer screw gauge depends on the principle or on the rules of screw. Okay, they depend or rely on the principle of screw. So when the thimble is rotated, the spindle moves linearly or straight due to the screw threads. Okay, when the thimble is rotated or when the thimble is rotating, the spindle moves straight or linearly due to screw threads. The pitch of the screw determines how much the spindle advances for each rotation. Okay, the pitch of the screw determines how much the spindle advances for each rotation. The circular scale and linear scale are combined to provide the precise readings. The circular, so to come up with the final reading, we need to add the linear scale or sleeve scale or the main scale to the circular scale or thimble scale. Okay, so these are three working principles of the micrometer screw gauge. Okay, so the next thing that we are going to look at, the steps that we need to follow when we are finding the final reading. So the step number one, we need to identify the mark, or we need to take a linear scale reading. So when we say a linear scale reading, we are taking a mark from the sleeve scale. So remember I said on the sleeve scale, that is where we are taking the main scale. On the sleeve scale, that is where we are taking the main scale. Okay, so take the first step, take the linear scale reading at the sleeve scale to find the main scale reading. Okay, so remember, linear scale is also called main scale or sleeve scale. Linear scale is also called main scale or sleeve scale. Okay, step number two. The step number two, we are going to take or identify the mark on the thimble scale or circular scale. By the way, thimble scale is also called secular scale. So the secular scale is coming from the part called thimble scale. Take note, the number on the thimble aligns with the horizontal line on the sleeve scale. So on the thimble scale, we are not just taking a number, we are looking for the number that is coinciding with the line that is coming from the linear scale or the main scale. Okay, take note, the number on the thimble scale that aligns with horizontal line on the sleeve scale, and it is called thimble scale. So secular scale is also called thimble scale. So the next thing that we are going to do is to add the main scale, and the secular scale. By the way, the main scale is a sleeve scale and the secular scale is a thimble scale. So we are going to add the main scale reading and the secular scale reading. If the micrometer screw gauge has a least count, e.g. 0.01 millimeters, we are going to multiply the secular scale reading by this value before adding it. Okay, so this is one of the steps that will be taken as we'll be calculating, as we'll be finding reading on the micrometer screw gauge. We have an example here. So, for example, if the main scale is reading 5.5 millimeters and the secular scale is showing 28, we are going to multiply 28 by this number, which is 0.1. So we are going to say 5.5 millimeters plus 28 times 0.1 millimeters, and we are going to get 5.78 millimeters. 5.78 millimeters. So this is how we can find the final reading. By the way, you are free to pause the video and assimilate the information given on the screen. So we are also going to look at precautions that we need to take before using the micrometer screw gauge. So what do we need to consider, or what precautions do we need to put into consideration before using the micrometer screw gauge? Okay, so number one, we need to ensure that the micrometer screw gauge is clean, spindle and anvil in particular. So these two parts of micrometer screw gauge need to be clean. Okay, need to be clean and free from dust, grease, and other particles that may cause wrong readings. Okay, dirt can interfere, or particles, or dust, or grease can interfere with accurate measurements. So therefore, we need to make sure that the micrometer screw gauge is clean. Step number 2, zero adjustment. So we need to check the micrometer screw gauge. After checking the micrometer screw gauge, we need to make sure that it reads 0 when the spindle and anvil are in contact. So when the micrometer screw gauge is closed, the micrometer should read 0. If not, adjust the 0 setting to prevent errors in measurement. So if the micrometer screw gauge is not reading 0 when the spindle and anvil are closed, we need to make sure that we adjust the 0 setting. so that we can have accurate readings or accurate measurements. Okay, the last precaution that we need to consider: apply gentle force. Avoid excessive force when turning the ratchet. So we need to be gentle when turning the ratchet. Don't apply excess force. Use the ratchet stop or thimble gently to avoid damaging the screw threads and distorting the object being measured. So these are precautions that we need to consider before taking a final reading on a micrometer screw gauge. Okay. So we are going to solve some examples here. We have an example: find the final reading. So how can we find the final reading? So we are given the schematic diagram of micrometer screw gauge here. So we have two scales. We have this one, and we have this one. So the first thing that we are going to do, we are going to identify these scales. So the first scale is called main scale or sleeve scale. Main scale or sleeve scale. So this one is a main scale or sleeve scale. Then this scale is called circular scale or thimble scale. Here we should have thimble scale, circular scale or thimble scale. Here, thimble scale. Okay. Thimble. Thimble scale. Okay. So the first thing that we are going to do is to identify a mark on the main scale or sleeve scale. We are going to identify the mark on the main scale or sleeve scale. So here we have 0, 0.5, 1, 1.5, 2, 2.5. So this is the last mark on the main scale. So therefore on the main scale we have 2.5. On the main scale we have 2.5. Then on the circular scale we are going to find the mark that is coinciding with the horizontal line coming from main scale. So the mark that is coinciding or the mark lining align with the mark or align with the line coming from the main scale is this one. So as we can see here we have 20. So this is 20, 21, 22, 23, 24, 25. So this is 23. Okay. So the mark on the circular scale is 23 millimeters. 23 millimeters. So we are going to say the main scale is 2.5, which is here. 2.5, which is here. Then the circular scale we have 23. So we are going to multiply 23 by 0.01 and we are going to get 0.23 millimeters. 0.23 millimeters. So according to the steps we have discussing, the next thing that we are going to do here, or the next step that we are going to take, is to add these two numbers, 2.5 and 0.23. So let us add these numbers. So we are going to say final reading is equal to 2.5 plus 2.5 plus 0.2. We are going to get 2.73 millimeters. So this is our final answer. So as we can see, we have successfully managed to find the final reading. Let us move to the next example. So we have added these two numbers. We have added 2.5 and 0.23. We move to the next example, which is example 2. Find the final reading. Find the final reading. So this is our main scale. This is our sleeve scale, or this is our linear scale. This is our thimble scale, okay, or this is our circular scale. So like we did in the previous question, even here we are going to identify the mark on the main scale. Let us identify the mark on the main scale. So this is the 7.5, 80, 8.5, 90, 9.5. So our answer is the mark on the main scale is 9.5. 9.5. 9.5. So this is the mark, which is 9.5. Let us also identify a mark on the sleeve scale or circular scale. So we are also going to identify the mark on the sleeve or circular scale. So this is the sleeve scale or circular scale. So to identify the mark on the sleeve scale, we need to find the mark that aligns with the horizontal line from the main scale. So this mark is here. So this is the mark we are talking about. So as we can see here, we have 0, 0, 1, 2, 3, 4. Okay. So this is the mark. So this is it. This one should be, sorry, this one should be 2, not 3. This one should be 2, not 3. Okay. So the next thing that we are going to do, we are going to say main scale. So we are from saying main scale is equal to 9.5. Then the circular scale or thimble scale is equal to 2 times. So here we should have 2. Here we should have 2. Okay. Then the final reading, we are going to add this number and this one, and we are going to get here we're supposed to have 2. So we are going to get 9.52. 9.52. So here we are going to have 2. 9.52. Here 2. Even here 2. Okay. So we are going to get 9.52 millimeters. 9.52 millimeters. Okay. 9.52 millimeters. Let us move to the next example. We move to our next example. So as we can see, we have added 9.5 and 0.03. We move to the next example, which is example 3. What is the reading on the micrometer screw gauge below? What is the reading on the micrometer screw gauge below? Okay. So even here, the first thing that we are going to do is to find the mark on the main scale. So this is our main scale or sleeve scale. Our main scale or sleeve scale. Okay. So this is the locking lever I was talking about, or locking nut. This is the locking nut. Okay. So we have seen that here we have 1, here we have 0, 0.5, 1, 1.5, 2, 2.5, 3.3, 3.5, 4, 4.5, 5, 5.5. So the last mark before the sleeve scale is 5.5, 5.5. And the mark that is coinciding with the horizontal line from the main scale is this one. So this is 25, this is 26, this is 27, this is 28, this is 29. This is 29. So therefore, we are going to say the main scale, which is here, is 5.5. Then this is 26, 27, 28. So the mark that is coinciding with it, the line from the main scale is 28 millimeters. Okay, so the next thing that we are going to do is now to add these numbers from two scales, one from the main scale and this one from the sleeve scale. So we are going to say the mark from the main scale is 5.5 millimeters and the mark from the sleeve scale or circular scale is 28. 28 times 0.01 is equal to 0.2 millimeters. Now let us add these two numbers, 5.5 and 2.8. We add these numbers to get the final reading. We are going to get 5.78 millimeters. 5.78 millimeters. So this is our final reading on this micrometer screw gauge. Okay, let us move to the next example. So we have added 5.5 and 0.28 millimeters. We move to the next example, which is example 4. What is the reading on the micrometer screw gauge below? Okay, so even here we are going to do the same. The first thing that we are going to do is to identify the mark on the main scale. So the mark on the main scale is 6.5. Why are we saying is 6.5? This is 5, 5.5. This is 6, 6.5. So the mark on the main scale or the mark on the sleeve scale is 6.5 millimeters. Let us also locate the mark on the thimble scale or the mark on the circular scale. So the mark that is coinciding or the mark that aligns with the horizontal line from the main scale is this one, 0. So as we can see, we have 0 mark here. We have 0 mark. So the mark that is coinciding with the horizontal line from the main scale is 0. Okay. So to find the final reading, we are going to say main scale is equal to 6.5. Then the circular scale or thimble scale is equal to 0 times 0.01. We are going to get 0.0. Okay, let us add these two numbers to find the final reading. We are going to say 6.5 plus 0.0. We are going to get 0.5 millimeters. 0.5 millimeters. 0.5 millimeters. So this is our final reading. We move to the next example, which is example 5. We have example 5 here. What is the reading on the micrometer screw gauge below? What is the reading on the micrometer screw gauge below? Okay, so as usual, the first thing that we are going to do is to identify a mark on the main scale. Then from there, we are also going to identify the mark on the sleeve scale. So the mark on the main scale, here we have 5. Okay, let us start counting from here, 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5. So the mark on the main scale is 6.5. The mark on the main scale is 6.5, which is here. If you pay attention to this mark, or if you pay attention to the readings or marks given on the sleeve scale, you are going to discover that this is 6.5 millimeters. 6.5 millimeters. From there, we are also going to identify the mark that is coinciding or the mark that aligns the mark that aligns with the horizontal line from the main scale, or from the sleeve scale. So the mark that aligns with the mark from the sleeve scale is this one, and we have 25 millimeters here. So this is 25 millimeters is our secular scale, or secular mark. Is our secular mark, is our mark from the secular scale. Now let us add these numbers. So to add these numbers, we are going to start with the main scale. We are going to start with the main scale. Do we have the main scale? Do we have the main scale? Yes, we have the main scale, which is 6.5. So we are going to say the main scale is 6.5 millimeters. Do we have the secular scale or thimble scale? Yes, we have the thimble scale or secular scale, which is 25 millimeters, which is 25, so to say. So 25, we are going to multiply 25 by 0.01 millimeters, so that we can get the mark from the sleeve scale. Sorry, I have made the mistake by saying 25 millimeters. It is not 25 millimeters. We'll call it millimeters after multiplying with 0.01. So we are going to say secular scale is equal to 25 times 0.01 is equal to 0.25 millimeters. So this is when we can call it 0.25 millimeters after multiplying it with 0.01 millimeters. Now let us add these two numbers, or two marks, from both scales. So we are going to say final reading is equal to 6.5 plus 0.25. We are going to get 6.75 millimeters. We are going to get 6.5 millimeters. So this is our final reading. This is our final reading. Okay, we now move. Okay, we have enough examples. Now let us extract some questions from past papers, so that we can see how best we have understood this topic. So the first question is coming from 2022 past paper, as shown here. So this is 2022 past paper. Okay, and the question is question B1. Figure B1.1 shows part of the micrometer screw gauge. Okay, question B1A, Roman numeral 1. What is the reading on the micrometer screw gauge? What is the reading on the micrometer screw gauge? So as usual, the first thing, or the first step that we are going to take, is to identify a mark on the main scale or on the sleeve scale. So which one is the main scale here? So this one is the main scale, and this one is a sleeve scale. So let us identify a mark on the main scale. So 20 is the last mark on the main scale, according to what we are shown here. Okay, so 20 is 20 is our last mark. 20 is our last mark. Let us also identify the mark that aligns with the horizontal line coming from the main scale. So this mark that is coinciding with this line that is coming from the sleeve scale is 30. Is 30. Okay, so we are going to say 30. So we are going to say main scale is equal to 6. Sorry, here we're supposed to have 20, not 6.5. Not 6.5, we're supposed to have 20. Then, okay. Let me edit here. You are going to excuse me. Let me edit. I'm going to edit here. Let me do something. I'll discard. Okay. Let me edit. I'll edit. So here we're supposed to have here we're supposed to have supposed to have 20. It's supposed to have 20 millimeters. Then here 30. Here we're supposed to have 30. Then here we are going to get 3 0. Okay, 30. Then we are going to get 20.30. 20.30. We are now good to go. We can continue presenting. Okay, so the mark from the main scale is 20 and the mark from the sleeve scale is 30. So the main scale is equal to 20 and the circular scale is equal to 30 times 0.01 is equal to 0.03 millimeters. So to find the final reading, we are going to say 20.3 millimeters. So this is our final reading. This is our final reading. So we have added these two numbers. So forget about this one. Our correct answer is here. So this is our correct answer. The next question, which is question A, Roman numeral 2, state one use of micrometer screw gauge. Okay, so we know that the function of micrometer screw gauge is to measure small lengths, thickness, and small diameters. So we are just going to say the function of the since we are told to state one use, we are going to say micrometer screw gauge is used to measure length of the small objects. Okay, micrometer screw gauge is used to measure length of the small objects. We are also going to answer this question, which is coming from 2010 past paper, and the question is question 1. Figure 1.1 shows part of a micrometer screw gauge, an instrument used to measure physical quantity. What is the reading shown on the micrometer screw gauge? So even here, we are going to start by identifying the mark on the main scale. So the mark on the main scale is 4.5. So this is our last mark. So here we have 1.5, 2.5, 3.5, 4.5. So let us also identify a mark on the sleeve scale. So a mark on the sleeve scale is 31. Here we have 30 and here we have 31. So this is the mark that aligns with the horizontal line coming from the main scale, and this mark is 31. The mark is 31. So to find the final reading, we are going to say main scale is equal to 4.5 and the circular scale is equal to 31 times 0.1 is equal to 0.3 millimeters. We add these numbers, we are going to get 4.8 millimeters. So for 4.8 millimeters is our final answer. 4.8 millimeters is our final reading. Okay, is our final reading. Let us move to the next question, which is question B. What physical quantity is measured by the instrument? So if you remember very well, I said micrometer screw gauge is one of the instruments used to measure length. So micrometer screw gauge is used to measure length. What is the function of the ratchet? What is the function of the ratchet? So we looked at the parts of the micrometer screw gauge, and we said the function of the ratchet is to ensure consistent pressure is applied for accurate measurements. We need the role of the ratchet is to make sure that consistent pressure is applied for accurate measurements, so to say. So as we can see, we are done with this question. Let us also answer this question, which is coming from 2015 past paper. 2015 past paper. And the question is question 1. The diagram below shows part of the micrometer screw gauge. What is the reading shown in the diagram? What is the reading shown in the diagram? Okay, so as usual, the first thing that we are going to do is to find the final, is to find the reading, or to find the mark on the main scale. Find the mark on the main scale. So this is 5.5, 6 is 6.5, and we are also going to find the mark that aligns with the horizontal line coming from the sleeve scale. Okay, so the mark from the sleeve scale is 6.5 millimeters, and the mark from the thimble scale, the mark from the thimble scale is 19 according to the numbers given here. So on top we have 20, and here we have 19. So therefore we are going to say main scale is equal to 6.5, and circular scale is equal to 19 times 0.1 is equal to 0.19 millimeters. Now let us add these two numbers. To find the final reading, we are going to say 6.5 millimeters plus 0.1 millimeters. We are going to get 6.69 millimeters. So this is our final reading. So therefore, our correct answer here is our correct answer is B. Our correct answer is B. So sorry, our correct answer is A. Our correct answer is A. Let me do this. Our correct answer here is our correct answer is A. So this is our correct answer, which is 6.69 millimeters. So this is how we can find the final reading on the micrometer screw gauge. We are also going to extract this question from 2024 past paper. This is GCE. And the question is question B1. Figure B1.1 shows an instrument used to measure a physical quantity. What is the reading shown on the device? What is the reading shown on the device? Okay. So even here, the first thing that we are going to do is to identify a mark on the main scale. So this is our main scale. This is our sleeve scale or circular scale. So here we have 5, 5.5, 6, 6.5, 7, 7.5, 8, 8.5. So our mark on the main scale is 8.5. Let us also identify the mark on the circular scale. So the mark that aligns with the horizontal line from the main scale is this one here. So this is the mark that aligns with the horizontal line from the main scale. And this mark is here we have 20, here we have 20, this is 22, this is 20, sorry, 20, 21, 22. So this is 22. Okay, this is 22. Okay, so we are going to say the main scale is equal to 8.5 millimeters. The circular scale is equal to 22 times 0.1 is equal to 0.2 millimeters. Let us add these numbers. So we are going to say 8.5 plus 0.2, we are going to get 8.72 millimeters. 8.72 millimeters. So we have answered this one. Let us move to the next part of this question, which is question B. Name part B. Name part P. Name part P. Name part P. So which one is part P? So part P is here. So they want us to name part P. Okay, they want us to name part P. So to name part P, we are going to bring this one here. So as we can see, part P is a spindle. Okay, part P is a spindle. Part P spindle. The next question, which is question C, what is the main function of the part labeled E? What is the main function of the part labeled E? So let us identify the part labeled E. So where can we find the part labeled E? So this is the part labeled E. Okay. So the part labeled E, this one is a ratchet. Okay. Is a ratchet. I mean the function of the part labeled E. So part E is a ratchet. So what is the function of the ratchet? So the function of the ratchet is to ensure consistent pressure for accurate measurements. So the role of ratchet is to make sure that there is consistent pressure applied for accurate measurements. Okay, so to attain the accurate measurements, consistent pressure is needed. The last part of question B1 from 2024 past paper, which is question B1D. Give one precaution you will take before using the instrument. So the instrument we are talking about here is a micrometer screw gauge. So I gave the precautions that we need to put into consideration before using the micrometer screw gauge. I gave 3. Number 1, you need to make sure that the micrometer screw gauge is clean. Number 2, apply uh, uh, apply force gently. Number 3, you need to adjust 0, or you need to make sure that the micrometer screw gauge reads 0 before start using it. Okay, so we are going to say ensure that the micrometer screw gauge reads 0 when the spindle and anvil are in contact. So when we are saying they are in contact, there is no object there. The instrument is closed. It has no objects to measure. So when the instrument has no objects to measure, the instrument should read 0. Okay, to obtain accurate readings. So if you ignore this precaution, you are bound to get a wrong reading. So therefore, it is important for you to consider the precautions before using the micrometer screw gauge. Okay, so this brings us to the end of this video. So this brings us to the end